Hello and welcome to another LeetCode solution video. This is problem number 40, combination sum 2. For this problem, we're given a collection of candidates and a target number target. Find all unique combinations in candidates where the candidate numbers sum to the target. Each number in candidates may only be used once in the combination. Note, the solution set must not contain duplicate combinations. For example 1, we're given input candidates of 10, 1, 2, 7, 6, 1, 5, and a target value of 8. So our output would be 1, 1, 6, 1, 2, 5, 1, 7, and 2, 6. This is because all of these combinations add up to 8. For example 2, we're given an input candidates of 2, 5, 2, 1, 2, and a target of 5, and our output would be 1, 2, 2, and 5, and that's because these two combinations add up to 5. Let's go through an example. For this example, our candidate's input will be 2, 4, 5, 5, 6, and our target will be 10. The solution for this problem is very similar to the last video we did, which was the combinations. The main difference in this solution is that we can only use each candidate once in our combination. If you haven't seen the combination sum video, you should go check it out right now. It's on my channel. It's the most recent video, number 39 or something like that. Maybe the link would be like right here on the screen or something. I don't know. Who am I to say? I don't know. Who knows? So we're going to have our current combo variable and our temp target variable. Our current combo will keep track of our current combination of our candidates, and our temp target will be used to see if our current combination is valid or not. So first thing we're going to do is add 2 to our current combination, and we'll subtract that value from our temp target. So now our temp target's 8, and since we can't use the same value twice here, we're going to move on to 4. We'll add 4 to our current combo. Now our temp target is 4. We'll move on to our next candidate, which is 5, and our temp target is not greater than or equal to our current candidate, so we can't add it to our current combo. So since we can't add our next candidate and our temp target is not equal to 0, this is an invalid combination, so we'll have to backtrack. And now we'll try to add our next candidate to this combo, which is 5. Now our temp target is 3, which is less than our next candidate. So we have another invalid combination, and we'll have to backtrack again. And we'll move on to our next candidate. Our next value is 5, which we just tried, so we can skip it and move on to 6. And we'll add 6 to our current combination. Now we're at the end of our candidates, and our temp target is not equal to 0, so we have another invalid combination, so we'll have to backtrack again. We've exhausted all combinations with 2 as our starting value, so we'll move on to our next candidate of 4. And we'll try adding our next candidate, which is 5. Now our temp target is 1, which is less than our next candidate, and it's not equal to 0, so we have an invalid combination, so we'll have to backtrack. Our next candidate is 5 again, so we will skip that and move on to 6. Our temp target is now equal to 0, so we know we have a valid combination, so we'll add this to our output list, and now we'll backtrack again. We've exhausted all combinations with 4 as our starting value, so we'll backtrack to have 5 as our starting value, and our temp target is still greater than or equal to our next candidate, so we'll add it to our current combo, and our temp target is now equal to 0, so we have a valid combination, and we'll add it to our output. And now we'll want to backtrack again. Our temp target is less than or equal to our next candidate of 6, so we won't add that, and we'll backtrack again. And since we already tried 5 as our first value in our combination, we'll skip it and go to 6. And since we've reached the end of our candidates list, we can stop there and output our 2 valid combinations. Let's jump into the code. The first thing we're going to want to do is define our backtracking function, and we'll want to pass 3 variables to this function. The first will be our starting index, the second will be our target value, and the third will be our current combination. The first thing we're going to want to do in our backtracking function is check to see if our current combination is valid, and we'll do that by checking to see if our target value is equal to 0. If our current combination is valid, we'll want to add it to our result variable and return so that we can move on to our next backtrack. And our result variable will be defined later in our solution, in our main part of our solution, and that's what we'll use to output our valid combinations. Next, we're going to want to iterate through our candidates, starting from our start variable that was passed to us in the backtrack function. And when we're iterating through our candidates, we're going to want to check to see if we have any duplicates and avoid them. And we'll do that by checking to see if the value of our current candidate is equal to the value of our last candidate, and our index is no longer equal to our starting index. And if this is true, our current candidate is a duplicate and we'll skip it. Next, we're going to want to check to see if our current candidate is greater than our target value. If it is, we don't want to add it to our current combination and we'll want to just skip it. Next, we'll want to add our current candidate to our current combination. And now we can call our backtracking function again. And we'll want to pass it our current index plus 1 because we can't use the same candidate twice anymore. We'll want to pass it our target value minus our current candidate value. And we'll want to pass it our current combination. And finally, we'll want to remove our most recently added candidate from our current combination so that we can move on to the next candidate and check that sequence. That's it for our backtracking function. So we'll want to go to our main solution now. And the first thing we'll want to do is define our result variable. Next, we'll want to make sure our list of candidates are sorted so that we can accurately avoid duplicates. Now we'll want to kick off our backtracking by calling the backtrack function, and we'll pass it 0 for our starting value, our target value, and an empty list for our current combo. And finally, we'll just return our result variable. And that's it for our code, so let's run this. Had one small syntax error, accidentally spelled target wrong, so just fix that, and the solution should be good, so let's run it again. All test case passed, so let's submit. Our solution was accepted, so that's it for this problem. If you like this video and want to see more content like it, make sure to check out my channel. Thanks for watching.